That's what I like to hear. All right, so my name is Talon Rao, like Mr. Eaton said, and my capstone is on the importance of paleontology. So, some of you may be wondering, what is a paleontologist? Or paleontology in general? Paleontology is the study of long-lost life. And the way we study long-lost life is by digging up fossils out of the ground. Now, what is a fossil? A fossil, by definition, is as follows. From the National History Museum in the UK, fossils are physical evidence of prehistoric animals and plants. They tell us about the history of our planet, from climate change and evolution to diets and diseases. But for the sake of time, we'll just call them dinosaurs. A quote from Australian Museum in Sydney says, "Fossils are formed in many different ways, but most are formed when a living organism, such as plants or animals, dies and is quickly buried by sediment, such as mud, sand, or volcanic ash." Some of you also may be wondering, how does one become a paleontologist? There are many different branches of paleontology. For example, vertebrate paleontology, invertebrate paleontology, micropaleontology, paleobotany, biostratigraphy, and conservation paleontology. Most forms of paleontology require college experience. Quote from Paleolithical Research Institution says, "Although not all careers in paleontology require a graduate degree, many do. Depending on the position, this usually means either a Master's of Science degree or a doctorate. For example, all permanent tenure-track faculty positions at colleges and universities, as well as quartile positions at large museums, require a PhD, and most also require subsequent postdoctoral research experience." The most well-known branch of paleontology is vertebrate paleontology, which specializes in the stereotypical paleontology of digging up dead animals and putting them back together, like dinosaurs. An example would be Alan Grant from Jurassic Park. I hope that the audience will come away from my presentation with the understanding of how paleontology can help with climate change, and in my presentation I will go over the following topics: the theory of evolution, medical research, the discovery of dinosaurs, and the impact of humans' mental health. Paleontology has helped with bettering the understanding of our world. Known as the Age of Enlightenment, paleontology was first officially recognized in the 1700s, although that's not to say that this is when paleontology first began. A quote from National Geographic says, "Fossils were widely regarded as works of the devil or a higher power. Many people believed that remains had special curative and destructive powers. Many scholars also believed that fossils were remains left by events described in religious stories. This proves that people were aware of the existence of fossils but did not know exactly what they were. Fossils are usually seen as a bad omen because they represented death. This caused a peculiar man to come up with a theory. Charles Darwin was a naturalist who came from a wealthy British family that was fascinated with animals. He was also the same man who proposed the theory of evolution, better known as Darwin's theory. Pew Research Center, a private organization that values factual research, gives us a definition of Darwin's theory. "This evolution," Darwin wrote, "is due to two factors. The first factor," Darwin argued, "is that each individual animal is marked by subtle differences that distinguish it from its parents. Darwin, who called these differences variation, understood their effect, but not their cause. The idea of genetic mutation, and indeed the scientific study of genetics, would not arise fully until the early 20th century. The second factor," Darwin argued, "is that although variations are random, some of them convey distinct advantages. Superior camouflage, a heftier constitution, or a greater speed, for example, that better equip a creature to survive in its environment. A greater chance at survival allows for more opportunity to breed and pass on advantageous traits to a greater number of offspring. Over time, an advantage spreads throughout a species, and in turn, the species is more likely to endure and reproduce. Thus, over the course of many generations, subtle changes occur and accumulate, eventually morphing into bigger changes and possibly even new species. Darwin's theory not only changed how we look at the world, but it also changed the Bible. It also challenged the Bible as well. That's why Darwin was so hesitant to release his theory. Now, why is this important, you may be wondering? If this theory was never proposed, then we wouldn't have a reason for paleontology. The world would continue unbelieving that fossils were left by higher beings, and we would just, From the discovery of dinosaurs, we have also seen a societal impact as well. With the growing popularity of paleontology, it brought new jobs to the plate, along with a promising, fulfilling life. Keith Thomas, a professor of natural history at the University of Oxford, writes, "A man with a horse and a pick, and of course a rifle, could venture out west and, like his gold-seeking cousins, bring back untold wealth from the rocks. That fantasy carries much more weight than the reality of the scientist in a lab coat. Noting tiny details in endless trays of museum specimens and preoccupied more with statistics and geochemistry than the campfires in the Badlands. Paleontology isn't just a career, it's a lifestyle. And while yes, they are the stereotypical scientists in a lab coat researching things, they also go on adventures all over the world to heighten their research. To name a few places, the US, Canada, Africa, UK, all over Europe, and all over Asia. They do this so that way we can better understand our world and while also giving us a chance to ward off climate change. Climate change has been ravaging our world ever since the Industrial Revolution, and its effects have been felt now more than ever. Studying past ecosystems and carbon dating helps prove the existence of climate change by showing us the difference of carbon in the atmosphere and also differentiating between present and past conditions of the Earth. Paleontologists are also in cahoots with environmental scientists in order to come up with structurally sound predictions of our future. Rising global temperatures, rising sea levels, polar ice caps melting, and unpredictable weather patterns are all presently coming true as we speak. The temperature of our natural world is getting hotter and hotter, and it's no coincidence. This has been a result of human activity. A quote from the National Oceanic and Atmospheric Administration, a government-funded research facility, states, "The amount of carbon dioxide in the atmosphere has increased along with the human emissions since the start of the Industrial Revolution in 1750. Emissions rose slowly to about 5 gigatons in the mid-20th century before rapidly increasing to more than 35 billion tons per year at the end of this century." And that can be represented by this graph right here. With the increase of CO2, the Earth heats up because the gases trap the heat of our sun in the atmosphere. This in turn enhances the greenhouse effect to an abnormal proportion, which is causing the polar ice caps to melt and the sea level rising, which can be seen by this graph. Scientists say that the sea level has been rising faster and faster each year. Also, a quote from National Oceanic and Atmospheric Administration states, "Global mean sea level has risen about 8 to 9 inches since 1880. The rising water level is mostly due to carbonation of meltwater and glaciers and ice sheets, and thermal expansion of seawater as it warms. In 2023, global mean sea level was 101.4 millimeters above 1993 levels. making it the highest annual average of the statewide record. This will affect the world as coastal cities start to flood and tsunamis become more common. However, we need not worry because we have paleontology with us. And we may still have a chance to correct humanity's misstep. Conservation paleontology focuses on past ecosystems and ways that we may be able to save the foreseeable future. Paleontologists have been working with environmental scientists in order to combat the threat. Windmills are an example because the main issue we have is burning fossil fuels in order to power our world. But windmills don't produce CO2 while giving us power. The same can be said with solar panels and dams, although dams cause other problems like disrupting ecosystems, and the process of making a dam produces a lot of CO2. But nonetheless, solutions are being put in place, and paleontology had a massive role in getting us to this point. By identifying the problem and how it became the problem, paleontologists managed to help kickstart the idea of climate change, which also caused discussion on how to prevent it. Paleontology has also seen usefulness in the medical field as well. Although a fairly new concept, it has shown promise. Quoting Year and Jamitsky, researchers from the National Library of Medicine, in a recent review of the worldwide use of fossils, Year and Jamitsky reported on the use of Beltramites, Omnamites, and trilobite fossils, as well as echidna, branchiopod, oyster shells, shark teeth, and mammal fossils in medical research primarily used in Africa, Asia, and Europe. But it doesn't stop there, for there have been tests conducted to see if there was a practical use for fossils in medicine. Another quote from the National Library of Medicine reads that turtle shells can be scraped and administered orally as a sedative for very energetic and vigorous children. Being able to calm down children is a very useful thing. Let's say a kid is nervous about getting surgery or is having trouble trying to focus during class. This discovery could help calm the child down so that doctors or teachers can easily get the job done without stressing the kid out. Now, why am I telling you all about this? It's because paleontology doesn't get the recognition that it deserves. Compared to astronomy or environmental science, paleontology normally sits near the bottom of government aid. Funding is like fuel for science divisions. The better funding you have, the more you can do. Let's take NASA, the National Aeronautics and Space Administration. If they don't get the funding that they had now, then we would know a lot less about our solar system than we do. And we wouldn't be able to put people on the moon as often as we have. Paleontology falls into the same boat, and we know a lot less about our world than we should. Paleontologists are constantly competing with one another in order to secure grants that will fuel their research. Zach J. Quirk from the National Science Foundation of American Geoscience Institution is a PhD candidate from the University of Michigan, which is a major in paleobotany and paleoecology. He states increased competitions for grants and the need for pertinent socioeconomic broader impacts are causing concern. A grant is money that is given to a selected person who has shown promise, but making grants competitive makes for a hostile work environment where you're constantly worried if you'll be able to continue your research. And while paleontology may have gotten a spike of popularity thanks to Jurassic Park, it still gets very little funding. A quote from Riley Black, a science correspondent for Smithsonian Magazine covering fossils and natural history, says, "Paleontologists continually write to different foundations and societies in hopes of winning some of the more prestigious grants. Bring funding to the paleontologists. Among the biggest pools of which researchers apply in the government agency, the National Science Foundation, the overall budget of the agency is over $6 billion. but a relatively tiny slice of that pie goes to the paleontologists in a given year. As calculated by Dodson between 1983 and 2009, the NSF awarded 88 grants to carry out research on dinosaurs and their close relatives, totaling a relatively modest 11 million funds. This is how many grants were awarded to paleo science divisions, and this is like the rest right here. With the lack of funds and how little I hear about paleontology, I chose to make my capstone on what makes paleontology important. Not only because it's a cool topic, but because I want to see paleontology succeed. My plan is to put my capstone up on YouTube for the world to see. And also I want to put postcards on the exhibits at Fairbanks Museum so that way people can see the benefits of paleontology while gazing at the product of their work. I am an aspiring paleontologist. I have always wanted to be one since I was a kid. I first learned about paleontology when I watched Jurassic Park for the first time, which I mentioned previously in my presentation. And while it may be a silly movie about a dinosaur park where the dinosaurs break out, it turned into something so much more for me, and before I knew it, I became obsessed. I wanted to know more about the prehistoric creatures that used to rule the world and how they were wiped off the map with nothing remaining of them but bone. I wanted to know how humans went from tiny mice to what we are now. And as I learned more and more about paleontology and how paleontology isn't just about digging up dinosaurs, but about learning about our origins of past environments and to better the world. It was no longer a hobby to me. It became something that I wanted to contribute to in any way, whether that be becoming a paleontologist or informing people on the good that paleontology has done either through a school presentation or some postcards. I hope that I can inspire others like I have been to look at paleontology as not just a hobby that some people took too far for fun, but as a serious career that is actively changing the world and will be for the foreseeable future. This has been my capstone on the importance of paleontology. Thank you for listening.
Hey, Talon, thanks for all that information. So I wondered if you could talk a little bit more about how paleontologists are helping climate scientists understand historical periods when maybe the Earth heated in the past.
Well, it's mostly just like better understanding the past so that way we can better prepare for the future, if that makes any sense.
What kind of paleontology do you want to do? Are you still stuck on dinosaurs or have you branched out?
That's a good question. I think I'm still a little too obsessed with dinosaurs to move to anything else, but who knows, maybe it could change.
I know you briefly touched on it, but what other type of types are there? What other different types are there?
I'm sorry, could you repeat the question?
I know you touched upon it, but what other types of paleontologists are there? What types are there?
So basically, that was just a few that I named. There's quite a few more, but each branch specializes in its own thing. Vertebrate paleontology is the normal paleontology that you would see with the big dinosaurs, like T-Rex and stuff like that. Micropaleontology focuses on microscopic organisms that lived way back then. And paleobotany focuses on plants, essentially.
Down. Concerning climate change in your presentation, what would you have to say to scientists that work in fields like myceliology that claim that we are actually too far gone when it comes to stopping climate change, and that the best bet we have now is to only mitigate the damages that it can cause to the environment.
Well, on one hand, I feel like there's evidence to back that up. On the other hand, I don't really fully believe that, because if we tried hard enough, we could definitely change. We could definitely change how the world is right now, and I just feel like the biggest hurdle is getting everyone to actually comply with the changes.
Are you more interested in like discovering fossils or like learning more from them, or both potentially?
I want to say discovering fossils, because discovering a new species to me just sounds really cool, one that nobody's ever seen before. So probably discovering the fossils.
What's the most interesting species of dinosaurs you've studied so far?
All right. So my first slide. I really like this guy. His name is Utah Raptor. He's like the real version of Velociraptor from Jurassic Park. Can you tell I like Jurassic Park? Anyways, so he's just the real version of it. He has cool feathers. I just really like him. And he has a big claw on his foot.
Thanks for all those questions. That was better.